So you need to know something about stability in atoms, and it's not like we were like, oh, this is a good idea. Let's say that they have stability in these different positions. What it is that we found that atoms that have certain configurations don't want to do the same chemistry as their nearby neighbors, and then the question comes up is why? And some of it is because of this idea of stability. In the atom prefers half or completely filled. Of course, completely filled is better than half filled. But what that means is when you have a single orbit, it prefers to be all the way filled. And if it isn't all the way filled, it will do things to get electrons from other people so that it will be filled. So it may be more reactive trying to get that electron. It's not as big of an effect for the S. It's a little bit bigger of an effect for the P. You'll see this when we talk about trends in the next class. So right here, this would be an example of half filled. There is stability associated with being half filled. There's even more stability associated with being fully filled. And this would be fully filled right there where everything is all paired up. It's really important to keep these in mind. So if you look at helium, nitrogen, and neon's configuration, they all have some amount of stability. They are half and fully filled. This one's the half. They naturally want to keep or arrange their electrons in this configuration. In the S block, this slightly affects some trends. It's not that important in this part of the periodic chart. In the P block, this affects trends. There are exceptions in trends that are a result of something, nitrogen, being half filled and not wanting to give up his electrons as easily as other elements will. And then in the D block, this affects elements that have one electron before their half or fully filled D block elements. So elements that are one electron before half or fully filled. So what do I mean? So a D that's fully filled and half filled. Here's our D. This is our half filled D. And this is our fully filled D. So elements that are one spot away, so say they're missing him or they're missing this last one. Those are the elements that we're talking about. They actually end up being right. Let me see if I can get it. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it happens right here. It also happens lower. So when you have 4 d electrons, and then when you have, this will be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those elements are chromium and copper. They both start with C's, if that's helpful. But there's also a cobalt in there that starts with a C that doesn't apply. But those are 2 elements. And this is a very popular chemistry topic to get tested on and to understand. It's just a thing for Gen Chem people to learn about this. So let's look at what happens in just those cases. It's not just affecting a trend, but we're actually going to see an electron move to make this D block half or fully filled. So this is how they should be. If you look their configuration, their noble gas core is argon, and then they've got 2 S's and 1, 2, 3, 4 D's. So they have 2 S's, and again, that's argon over there. And then 1, 2, 3, 4 D's. And copper has argon. He has 2 S's and 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. Now I want to have a contrast, so I'm going to actually also fill these just so that you can see I'm filling it with the exact same way. Just trying to get them all filled up. So you can think this is like the before, and then this is going to be what really happens. What really happens is that this electron that was right here gets promoted over here. So chromium's configuration, it's not argon. Let me brought that. 4s2, 3d4. It's not that. That's not what it is. It ends up being argon 4s1, 3d, 5. And that's all because of stability. It's crazy that'll happen too, right? Only those elements or columns that this happens in. It doesn't happen when you're not at the 4 or the 9 position. But yeah, he does the exact same thing. Argon 4s1 3d10. Not argon 4s1 2 3d9. Which would be, that's what you would predict. That's supposed to be a 9, sorry, 3d9. This is what really happens, and this is the answer for those two. Now, this drawing configurations that we've just done so far, this is a Quizlet that helps with all the neutral atoms, and it helps drawing and like getting in order, get everything in order. So if you want some extra practice on a Quizlet, there you go. And go ahead and see if you can figure out the words to this, just whatever makes sense. And then I'll start with having all those filled in.